Hello, my name is Patrick Long, and today I am going to be talking about why a discus is stabilized / tries to stabilize itself while flying through the air. Before I start talking about the physics behind why a discus does this, here's a video of a full discus throw. Before we go straight into why a discus tries to stabilize itself / is stabilized while in the air, we are going to briefly touch on two topics that will segue into our main topic of discussion. The first thing we'll touch on is energy, more specifically the kinetic and potential energy that will eventually transfer to the discus. So here I have two straightforward definitions of kinetic energy and potential energy. Kinetic energy being the energy of an object with respect to the motion of the object, and potential energy being the energy of an object with respect to the position of the object. Now in this clip, we can see myself turning my upper body back and forth. This motion gives my upper body and the discus kinetic energy, and as I transition from turning from left to right, we can see the kinetic energy transfer to potential energy due to the muscles of my body being stretched. The energy is then transferred from kinetic energy to potential energy until I start to spin. Once I start to spin, the energy from me winding up is stored as potential energy in the shoulder of my arm, and stays as potential energy until I throw the discus. More energy is gained in the form of kinetic energy due to the spinning movement of my body. Then, as I throw, the energy gained is transferred to the discus. For the next topic, I will be touching on the topic of friction. Here, I give you the definition of friction and the coefficient of friction. Friction is the resistance that one surface or object encounters when moving over another, and the coefficient of friction is the ratio between the force necessary to move one surface over another, and the pressure between the two surfaces. Now, in this same clip, we can see that I am wearing special shoes. These shoes are designed for spinning and allow the coefficient of friction between my feet and the concrete to be as low as possible. So as I spin, I will be encountering the least amount of friction possible, allowing myself to transfer energy to the discus as efficiently as possible. Also, we can see the disc spinning. This is due to the friction between my fingers and the discus. This spinning action will be important in our final topic. After I have thrown the discus, we can see in this video here that the discus is a little wobbly in the beginning and then starts to stabilize itself relative to the angle that it was thrown. This is due to certain forces acting on the discus. Previously, we had mentioned that after the energy is transferred to the discus and thus is thrown, the discus spins. This occurs due to the friction between the thrower's fingers and the rim of the disc. So as it rolls off and leaves the hand, it gives the discus a spin. Now from the moment the discus starts to spin off your hand, it begins to gain angular momentum. Here's a definition of angular momentum, and it is the quantity of rotation of an object which is the product of its moment of inertia and its angular velocity, and is expressed as a vector. We also can see what direction the angular momentum vector is pointed by using the right hand rule. It works by curling your fingers in the direction that the discus is spinning and finding the direction your thumb is pointed. By doing this, we find that it is perpendicular to the discus and pointed down. So, as the discus spins faster and faster, it gains more and more angular momentum. And as the angular momentum vector increases, the discus will stabilize. This is because the axis of angular momentum, which is the direction of the vector, becomes more and more resistant to change as the discus spins faster and faster. This causes the discus to stabilize itself as seen in this clip. This also occurs while you ride a bike. Not moving on the bike will prove to be a challenge when trying to stay upright and balanced. But if you're moving, the spinning of the wheels would create an angular momentum vector that would resist change, making it easier to keep the bike upright and balanced. In addition, if you were to watch Olympic athletes throw discus, you would see that their discus is stable and flat relative to the angle that they threw it at. This is because they transfer so much more energy into the discus, allowing it to spin faster, causing a greater angular momentum vector than what I produced. Thank you for watching this video. I hope you learned something new from it.